All right, can you hear me? Am I coming through now? Hmm. What? Okay, so you guys. Okay, so there's this stupid button on this headset that I sometimes accidentally hit. So I will start over. Um, what I was talking about for the first few minutes is that the end of the semester is May 29th, so I do not accept any work after Friday, May 29th. So please just keep that in mind. If you're behind or you're slow to catch up on the final lab next week. So we have a lab this week. We have Project 4 due this week. Both of those due by Sunday, like we've been doing. And then we have one final lab next week that we will complete together on Tuesday. It's worth 300 points. So that's really just a bonus 200 points for what's mostly a normal lab. But the closeout date when I will just not accept anything else is May 29th. So just please keep that in mind um, for planning your activities. Okay, so I have kind of two things, and I've got a mess, and I messed up from my earlier class because the thing that we didn't work, which is very frustrating. Um, so I'm probably going to need this projector. Okay. Okay, so we have a lab. This lab is part of the project. So what we do with the lab today is part of the project, and I expect to finish the lab today, and then I will try to help you um, remind you how to tie in some pieces for the project that's due this weekend, Project 4. So this word class that we're working on is needed for the project. I'm going to do a little bit of setup about the star of the show is overloaded operators. They're scary looking at first. And hopefully this is a gentle introduction to them, but let me show you what I'm referring to. So right here in the word class, there are these operators. So there's the equivalency operator, the greater than operator, and the less than operator. Oh, and there's also the output operator, which we call the insertion operator. In C++, you can do what's called overloading operators. And what it means to overload an operator is to take a known operator like equivalency and redefine it to behave differently with your own types. Now I'm going to do a manual one here before we do this word class. So overloaded operators is kind of the big new thing in the lab this week. And then the other thing that some people will find takes a little bit of thinking on is that we're gonna take this word, we're gonna make objects of this word, and we're gonna put it in a binary search tree. So the nodes in the tree are gonna have word objects in them. But let's just get a quick introduction to operator overloading first, and then we'll deal with the lab and the binary search tree. One thing I wanted to show you, by the way, the code for a tree is not provided, but if you look at the test, so I'm looking at the Lab 16 unit test. So here's a test case for the word class, but if you go down here to the bottom, there's a test case for a binary search tree that includes the word class. So to make the lab work, you're going to need your binary search tree that you completed last week. I actually have Jordan's here, which probably was the last one that I was reading through as I was grading the labs. But hers works perfectly, so I'm going to use hers. Anyway, you need a binary search tree in your folder. So note my folder has, I made a copy of binary bstree.hpp and I put it in my lab folder with the files that came with the lab. So you need that file or it won't compile. Just pointing that out. So take a second. You don't need it right this second, but at some point you need
a copy of that file in this folder. Okay. So new file. This is just a little bit of introduction to operator overloading. So I'm going to do C++ file. I know I'm going to end up doing some outputs. I'm going to use a string also. So it was already in my plans to do that. And I'll just call this experiment.cpp. So I called it experiment.cpp. It's just a little experiment I'm doing off on the side because I want to introduce you to the concept of operator overloading. Okay, so let's say I have a class called box. And I'm going to do this relatively quickly so we don't spend tons of time on the example. You have a class called word, but we're going to make a class called box. Let's give it contents. Let's give it an integer weight. And then we'll make a constructor for it. Now I'm going to just sort of do lazy person's constructor here, string contents, weight. I'm going to use an initializer list for this. I like the way Adam does this, by the way, because this red contents, or at least for me it's red, whatever color you're seeing it in. Notice that the member contents, pardon me, is the same color, and the parameter contents is the same color, and that is good because that's correct. In this initialization list, followed by an empty block, you have the member being initialized to the parameter, and then you have the member weight being initialized to the parameter weight. That's just a constructor, right? That's all it is. All right, now let's go make a main, and let's make a couple of instances of box. So I'll just do box B1. I'll say this one has a cotton in it, and it weighs like a pound. And I'll do a box B2 that has lead in it, and let's make that weigh like 100 pounds using my constructor. So if I were to try to do this, I'm going to get a compiler error, and I just want to show you the compiler error. But what I'm trying to do here is I'm trying to see if B1 is less than B2. Most people can make sense of the idea that what does it mean for my new box to be less than another box. But let me just show you what C++ does with this. Over here, please. Thank you. Okay, so to get just a wall of errors, but the error that it's complaining about, you can kind of find it pretty low on the screen down here. It's down here where it says operator less than, and here's another operator less than and an operator less than. And what it's complaining about is that this box is something that I just invented today. And C++ doesn't know what it means to compare one box to another. Does that mean compare its contents? Does that mean compare its weight? Does that mean compare its weight and its contents? C++ doesn't actually know how to do that. So C++ allows you, and not all languages do, C++ actually allows you to define what it means to compare two boxes by overloading the operator. So it's overloading. Operators. So I'm going to overload this operator. The less than operator. This is how it's typed, not with the space. Smushed together. So this is a new way to think about what operators are, but really operators are just functions who are called in a funny way. The way you call, for example, in this case, I'm calling the function less than uh, with two arguments, b1 and b2. Calling it with two arguments, b1 and b2. It's just not what you're used to thinking about when you see an operator. But what an operator actually often is a function being called with some arguments. Now, in the case of comparisons, one of the arguments I can think of is this. The caller is b1. The argument is b2. And the way you would do that in this case is you'd say this and the other box. And what we'd do here is we'd say, let's say we return this weight is less than the other box's weight. So I have just created a definition for what it means to compare one box to see if it's less than another box. And what I have said it means is to take this box, the caller, which in our case is B1, and see if its weight is less than the other box's weight, which is the second argument, B2. That's going to be false. So let's say else. All right, so now let's compile that. So B1 is heavier. That's actually stupid, by the way. B2 is heavier. B2. But just the outputs didn't make logical sense. Obviously B2 is heavier, or B1 is lighter. I'll say B1 is not lighter. That's easier to understand. So I have just overloaded this operator so that you can now take a box object and compare it with another box object. And you can do this with all kinds of operators. The easiest ones are the comparisons. So let's compare two boxes to see if they're equivalent. And in this case, let's say that this contents equals the other box's contents, and this weight equals the other box's weight. And I'm just doing this to point out to you that you can make this comparison mean whatever you want. I'm going to make a B3 here and fill it with cotton at 1 pound, and then use my overloaded operator. So I've redefined the equivalency operator so that it works for boxes. I should have a return down here, by the way. So if B1 is equivalent to B3, so you sort of have to get used to this, but B1 is this part of the equation, and B3 is B, it's the other box being sent in, and this is the function, the operator equals. And I'll say B1 and B3 are equivalent. Which is what I expected, because they have the same contents and the same weight. So that's all that is. There is one scarier looking one. So you can also, and I'm going to do this as a friend. All I'm going to say, since we sort of don't have the convenience of having a good discussion about this, is that this is pretty typical for this particular operator. So you just sort of get used to this setup for now and worry about the others later. Um, friend is just sort of an access kind of thing. Friend functions can actually use private data members. But we'll see another example of it in a second. So a friend is a special kind of function, and it turns out that it's not even actually a part of the box class. It's just a friend to the box class. So anyway, this is how the output operator actually works. It returns a reference to an output stream, which is super confusing at first. But it's going to look something like this. So all I'm doing is I'm saying, well, let me show you what I want to be able to do. So what I want to be able to do is this. Why? What died? Something died. Weird. B1. So what I want to do is something like this. My computer's acting a little funny, so I've gotten a little paranoid here. What I want to be able to do is just take a box and put it on cout, but it turns out that C++ doesn't know how to do that. It doesn't know how to take an output and put my box with it. So I have to define the functionality to do that. So this is a little bit different because it's a friend function. But notice in this case, I have an output placed, cout, and I have a box. So in the case of this friend function, the output is actually the first argument, the thing to the left, and the box is the second argument, the thing to the right. So it looks a little different. And this is pretty intimidating at first, but you just sort of learn to recognize the setup and go with it. Once you're here, though, then you just take outs and you do whatever you want to with it. So in this case, I'm going to say b.contents, and then I'll say ways b.weight pounds. And then you have to return outs. Outs is this thing. It's up to you whether or not you want to put a new line. I did not. So I realized that those are pretty intimidating looking at first. So here's cotton weighs 1 pounds, which technically wasn't correct, but so there's some overloaded operators. So this is really, this lab this week is just exposing you to the idea. It also turns out that you can't put word objects in our binary search tree without some of these operators. So the project actually needs it, but your takeaway is that you can do this in C++. You can redefine operators to do different things on your custom classes or structs. So I did a box struct here, a box class, and I overloaded a few of the operators. There's a lot of operators in C++. All the arithmetic is operators, plus, minus, times, divide. The square brackets is an operator. The parentheses is an operator. It turns out that you can redefine a lot of what you sort of think of as built-in things in C++. That's the main takeaway. Okay, so we're about to see this in the lab. So let's go look at the lab. Here's word.h. So the first thing I'm going to do, and this would be a good time, and I'll hit pause for like 2 minutes. So you can go get your tree and put it in your lab folder, so that we can compile and run fail tests for a while. And then I'll explain to you kind of what's going on with the tree part of the test. But our first job is simply to implement this class. And we're going to note, and you're going to see this, here's the friend. So notice friend, OStream, that ampersand can go anywhere. And operator, And then we have the outs, just like we just did, although I put the ampersand over there in that case. Doesn't really matter. Anyway, this one has a word instead of a box because we are inside of the word class. And then you'll notice there's some comparison operators. So those will be less scary because we'll compare this something with target something. Compare this something with target something, this something with target something. And then we have the funky friend one. Okay, so remember the friend. That one is a weird one, so just when we get to that, heads up about that. Let's see what word.cpp has in it. Does it have anything in it? No. So let's go grab headers and copy those over. So I'm going to grab all these things, put them in my CPP file. I think I can shrink the text a touch. I hope I'm not shrinking it too much. Okay, and then I do the typical, right? I put the word colon colon on front of all these when they're separated. So the operator functions also get it. Those are functions that are being defined for a word. Okay, so now when we get to the friend one here at the bottom, just heads up about this. So heads up about the friend one. Friends are not part of the word class. They're weird, kind of, they look like they're part of the word class because they're declared in the word class, but they're actually not officially part of the word class. They are just friends to the word class. And you only have to use the friend part in the header file, the .h file. You do not repeat, in fact, don't repeat friend in the CPP file. But notice I did not put word colon colon here on this particular operator, this friend one, because it's different and it's weird. It's a friend to word class. It is not a member of or truly a part of word class. It is a friend to it. But I also don't repeat the word friend in the CPP file. So there it is. And I'm going to stub these out. I'm going to work my way up from the bottom now. To stub this one out, let's just return outs for starters. And then we're just going to stub them all out, and then we'll go back and fill them in later. So comparisons, they return true or false, so I'm just going to return false on the comparisons to stub them out. So there's the three comparisons are just return false. Those are stubbed, meaning they are not complete. I'm going to fill them in later, but I want to be able to compile right off the bat. And then the way I stubbed the friend function, and notice how different it is. It does not have word colon colon on it because it's not actually part of the word class. It is a friend to it. I stubbed it out by returning outs, which is this thing. That one's just weird. Okay, so I'm going to continue working my way up and stubbing. So increment count. And of course I'm taking the semicolons off. That's a void function, so a stub for that means nothing. This one, unsigned int, so I'm just going to return 0 to stub it out. Get word, so to stub that one out, I'm just going to return an empty string. Set word is void, so to stub that one out, I can just leave it empty. The overloaded constructor, I can just leave it empty to stub, and then the default constructor, I can also leave it empty to stub. So I stubbed them all out. I have implemented nothing, but I want you to do this because I want you to sort of find the problem with this insertion operator overloading early. Um, Notice that I took the word friend off in the CPP file and I did not put word colon colon. So I'm taking all the time to say this, and I guarantee you someone's going to send me something that says it doesn't work and there's going to be word colon colon on there, or it's going to say friend here in the CPP file. So the best I can do without being able to see your code is just sort of stop here and repeat this a whole bunch of times. This particular function is just weird. It is a friend to the word class. Being a friend gives it special access to the variables, but it means also that you don't do word colon colon because it is not truly a part of the word class. It is just a friend to it. And then the keyword friend goes away on the CPP side. So in word.h, here's that function with the word friend on it, which tells C++ that this thing is a special function. It has special access, but it's not truly a part of this class. And I realize that that just feels really weird because it's declared inside the class. It's with the same code as the class. It's in the .h file. It's in the .cpp file. It's just not. It is a friend to it. It is not a part of it. Oh, I forgot I forgot up or down here. Better get that or it won't compile. So upper, I need that function also. That part is a part of the word class. And I'm going to stub it just by returning an empty string for starters. Now I did all that because I want to go compile. I want to get compiling quick. I'm going to specify the output file. XE. I don't have a catch. You're going to need a catch. So here's my current complement of files. Don't worry about a.out. So I have bstree.hpp. I have catch.hpp. These experiments you don't need for the lab. I just did that to introduce you to the concept of operator overloading, so you don't need that. I wish I didn't have it there. I'm going to move it out of the way so that it doesn't distract. Okay, so you have bstree in the lab16 folder. Catch lab16.cpp, that's the unit tests, which use the bstree. That's why it's here. You can also see that, by the way, in the includes up here. It also uses the word.h file. And then word.cpp, word.h. Which I've already made a mistake, by the way. Because when we compile, we need to compile word.cpp in. So please look at this compiler command that I'm using. Make sure that the CPP files all get compiled. I got lucky the first time because it complained about catch being missing. All right, so make sure that all the CPP files are in your compiler command. Now I expect to fail most of the tests, if not all of them. I don't really know. We'll see. I managed to pass 4 things by some miracle. I managed to pass 4 things somewhere. It's just showing me the fails. But I expected to fail. I just wanted to get compiling. So I want to be compiling. Okay, so now I'm just going to sort of do a few at a time of word.cpp. Okay, so if I go to word.h, I will notice that I have word that's a string and count that's an integer. Word, string, count, integer. So initialize with empty string. So it turns out that strings do that already, so I don't have to worry about that. Um, all I'm going to do is this count equals 0, because the string here that is called little w word, it's already empty. I'll put a note though. Word is already empty string. You don't have to do anything. In fact, I'll say this word. So this can be confusing. You have the word class, and then you have the word data element. So it's just kind of, I couldn't decide on the wording to use here, but you have the word class, which contains a string and an integer. The string happens to be called little w word. So little w word is the string inside of the big W word object. If I were to draw a picture of it, which I could do probably, yeah. If I were to draw a picture of it, here's big W word. And inside a big W word, I have little w word, which starts out as empty. That looks terrible. So I can get that closer. And then I have the count, which is 0. So a big W word is an object that has a little w word that's a string, starts out empty in it, and has a count. So a big W word is this. Little w word is that one field inside of it. And it also has a count. Okay, I'm going to do the overloaded constructor. I'm going to do some of the easy ones. So the overloaded constructor is initialize the big W word with the parameter word. So that's the member word, and this is the parameter word. And then no one caught me on the other. This first one says to have a 1 count for some reason. Make sure you get that. Empty string and count of 1. Not 0. But the string is already empty, so you didn't have to do anything for that. I got it for free. The overloaded constructor assigns the word parameter to the word objects field, and then sets its count to 1. Okay, so let's do, these are easy, right? So this one, word equals word. So we just take the word parameter and overwrite the objects field with it. Get word is easy because we're just returning the field. Get count is easy because we're just returning a field. Increment count is also easy, by the way, because it's just count plus plus. So just incrementing the field. Okay. So I'm going to compile it. That's enough, I think. That I should stop and see if I hit it with the compiler, is everything still okay? And then I'll see if I pass any more tests. I can scroll that up so everything that I just implemented is on the screen. All right, so I was passing 4, I'm passing 7 now, so that is some kind of progress. Just check in chat to see if anyone's got any questions. Those are all easy. Now we get down into the operators and this upper thing. Let's see. Okay, so case insensitive. So let's do this first one. It's going to require a little bit of thought. So returns true if the string attributes of the two word objects are equivalent. It's case insensitive, which means that it needs to convert them all to upper or to lower case. So that's the purpose for this upper function down here. So all we're going to do is say if upper of this word is equivalent to upper of the target's word. The target, we use a dot because it's just a constant reference. This is a pointer to sort of a self-reference. So we're using our upper function. So all we're doing in the case of this operator is saying, is this word uppercased match the target's word uppercased? That would be case insensitive. This next operator is the same dang thing. So it's just return if upper it. So if the upper of this word is greater than the upper of the target's word, case insensitive again. Lexicographical just means alphabetical order, by the way, for all intents and purposes. It does matter if things are upper or lower case when you're doing lexicographical ordering, so that's why we're just running the comparison as an all uppercase kind of thing. Less than, same dang thing. So we'll just compare uppercase this word with uppercase target's word. Okay. So that's a lot, but notice those are really small. All they're really doing is comparing one object's word uppercase to another object's word uppercase. The strings already can be compared that way, so once we get down to the level of the strings, then those can easily be compared. Makes that relatively easy. We do need to implement this upper thing. So I'm just going to show you the... do we have algorithm in here? We do have algorithm. So you can do this all in one fell swoop. We should be able to say transform s dot begin, s dot end, s dot begin. I think that just does it. Hopefully. We'll find out. But anyway, there's just a quick shot to transform an entire string all the way from the beginning to the ending. I forget what this is. I think that's where to overwrite the new data with. So basically this transform line right here transforms the entire string S from its beginning to its end into all uppercase letters. So it basically transforms each character of the string from the beginning to the end into uppercase form. We have not implemented this operator. I may save that one to next time, depending on the time. We might just finish so we can talk about project stuff. So that's a lot. Just going now to hit it with the compiler. doesn't like the standard, right? Let's see here. Could not convert standard transform. Let me see word.h. Okay, so let's see if the problem is just putting this standard in front of transform and see if that shuts it up. If it doesn't, we'll do something else. Yeah, it still complains. So what is it not happy about? Upper. Could not convert. All right, let's do this then. Um, um, yeah, let's do the transform on a separate string, which is what I'm guessing is the problem. It doesn't want to do it to the parameter, so we'll just make a new one called updated as a copy of s. Transform it and then return it and see if we get some love from the compiler. Okay, so I'm just going to point out to you what I did here. I was getting errors just trying to use s. So what I did instead is I made a new string named updated and I constructed it with a copy of s. So right at this moment, updated simply has the same contents as s. Then I fired off transform on that updated string. So I transform the updated string and then I return the updated string. I think I was trying to do too much in one place basically. But anyway, that compiles, and at that point then I can go back and try the test and see if I'm passing anymore. I'm passing 10, I was passing 7, so that's progress. And I know I'm making you consume a lot today, but I want to have plenty of time on Thursday to try to connect a couple of loose ends for you for the project. So I'm going to implement the overloaded operator, and then I'm going to go and review all the functions one more time, and then I'll sort of give us a stopping point and something to reconnect to next time. All right, so there's upper. The reason why we have that upper function is because these three overloaded operators need the help. So they all say that they're supposed to be case insensitive, which means that we can't just compare one word to another word. We need to uppercase them all so that the comparisons are case insensitive. And that was true for all of the overloaded operators. Okay, so now the string representation of the word on an output stream. So the trick here on these weird overloaded operator, these overloaded insertion operators, just think of outs as cout. Just pretend like that's cout. And what would I do with cout if I wanted to show that information about this word? So the word is called src. If I want the word inside of it, well, that's this part. That's the string inside of it, followed by a space, followed by its count. That's it. And then I return outs because that's how these weird overloaded insertion operator functions work. But if I just think of outs as if it were cout, then that makes the output part of this problem easy. Now we're about to see what happens on the tests. but it tells me basically the string inside of the object followed by a space followed by the count inside of the object. So if the string inside of it is apple and the count is 3, um, then that would be the output. So it's the word inside of it followed by a space followed by the count inside of it. So the test is telling me something. So I don't know if you can tell, but the test is kind of telling me that it expects that I've already uppercased all the words. So in this first test, for example, when it does get word, it expects that word to be all uppercase apple. Now, it probably started out as all lowercase apple, so what does this mean? Well, what it means is when we construct a word, what we should do is uppercase it right at the moment that we create it. So I'm in the overloaded constructor, and I'm going to do this in 2 different places, by the way. What the test is telling me is that it expects everything to always be in uppercase, which means that I need to do the work to make sure that it is. So everywhere where I get word data coming in, I need to uppercase it. So the overloaded constructor has that situation where I need to uppercase the parameter. So does setWord. I need to uppercase the parameter there as well. So I'm going to run that test and see if we now pass, which I expect to. So the test informed me that the expectation is that the word is always uppercased. And no one caught me on this. Look, on the overloaded constructor, it actually told me to do that, and I just didn't read it. I'm not the first one in our group to not read the notes, so I don't feel that bad. But there you go. The test sort of exposed my problem, but then now that I go back and look, converts the string param to uppercase. Converts the string param to all uppercase. So it was actually telling me that, and I was just being lazy and didn't notice. So now I pass all the tests. What this means, by the way, if we scroll down to the 3 comparison operators, the word can't ever be, you can't get a word object that has a string inside of it that's not uppercase. So I don't actually have to do any of this uppercasing down here because that's already done at the moment that words are created. So I can save the computer a little bit of work by not uppercasing here, since I already know they're always all going to be uppercase. So all 3 overloaded operators, I took away the uppercasing because that's already been dealt with somewhere else, in the constructor and in setWord. So I'm going to double check that just by recompiling it and rerunning the test, but I'm pretty sure that that problem is now being handled at the moment that a new string comes in. Okay, so still passing, so that's all good. I'm going to review those kind of quickly now because I wasted our time not having read the instructions. All right, so the default constructor, initialize the word with an empty string and count of 1. Since the word is a string, it's already empty, so I don't have to touch it. There's the count being 1. Initialize the word with the string param and convert the string param. So convert the string parameter to uppercase and then store it, and then the count is 1. Set word also says convert to uppercase, which I just didn't read. So uppercase it and then store it. Return the word, the string attribute, which is little w word. Return the count. Increment the count. So now when I'm comparing this word with the target's word, and remember this is a pointer, so this arrow word as opposed to target dot word, because the target is not a pointer. I don't need to uppercase those anymore because they're already uppercasing for themselves. Same for greater than. I just compare this word against the target's word. I don't need to uppercase anymore because that's already been done. Same for this less than. Just compare them because the uppercasing has been done. This friend function is by far the funkiest one. I wish there was a way to make it not funky, but it just looks funky always. So you just have to get used to it. No word colon colon on it. And take the word friend off on the CPP file. C++ already knows it's a friend, so you don't have to tell it twice. And then make sure that you have this return statement or the thing breaks. And then we fought this one a little bit too, the helper function that uppercases a string and returns the uppercase form of it. But it helped to break that down into more steps as opposed to trying to slam the whole solution into one thing. And then we compiled and ran the tests. So let me try to leave you with the thought about what's going on here. So this is what words look like. And so if you could have multiple word objects, right? So you might have, remember they get all uppercase now. You might have apple and a count of 3. And you might have another one that's whose word is banana and a count of 2. So that's the word. Class's job is to store a string and a counter to go with it. Now let me tell you conceptually why we're doing this, and then we'll see what it looks like in code next time. So conceptually why we're doing this is because we're going to make a binary search tree filled with these things. I need that slightly higher. So project 4 is actually taking words and making a binary search tree out of them. So here's my root, which would be null to start. But what we're going to do in the project is we're going to say insert, and then we're going to insert a word. Let's say apple. So we're going to insert a whole object called word class, right? So we're going to insert objects, word apple. So what happens if we insert apple in a tree right now? Well, it should be at the root. But you have to imagine now that if you look inside the root, you have a word object who has a little w word that says apple in it. You can't see that at all, I know. I should have drawn this bigger. I'm going to draw it bigger. If I do it this way, does it help? Word, apple. Root, closer. I know it's not really focusing. An account of 1. So that's what would happen if we did insert a word object with the string apple inside of it. The constructor would construct it with the word apple on a count of 1, and then the tree would put that word object in a node. So you have a node with the word object in it, and then inside of the word object, you have the string word, which is apple, and a counter. So it's sort of multiple layers. Now, if we were to insert, let's say, banana, because these have the overloaded operators in them, the tree would know to put banana after apple. That's what the comparison operators are for. It's like, oh, I will compare the word banana with the word apple, and that tells the tree that it needs to put the banana after. And of course, if something came before. All right, so here's the tricky bit, though. So we're going to have a situation on the lab where it's going to say insert the word apple again. And this is, again, just to sort of prep your minds for what we're going to do on Thursday. So what if we tried to insert the word apple again? Well, we're going to find that we already have the word apple in here. That's a problem because our binary search tree will not allow duplicates, and because that comparison operator is just comparing this word with that word, they're going to be equivalent. So what we want to do in the project, and I'll help you figure out how to do this on Thursday, what we want to do in the project is not put a whole node for apple in here, but realize that, oh, I've actually encountered that word a second time now. So we actually go in and we increment this counter saying, well, I'm only going to store the actual string once, but every time you try to insert that string again, I'll just, if it's already in here, I'll increment the counter. Hopefully that makes sense. So now if I were to insert apple again, another word object apple, it's going to immediately find I already have that a word object with that string in it, so I will just increment the counter. And so now the tree is saying, I've seen the word apple 3 times, or I've seen the word banana once or twice. So technically, the string is not in here more than once, but the tree is actually, we're going to write code so that we can actually keep track of how many times have we seen that word being inserted. So we won't insert more than one apple word holding object. We'll just increment its counter. So that's what we're going to work on Thursdays. What does that look like in code for the 4th project? So thanks for being patient. That one was a bit of a messy one, and I went fast because I want to work on project stuff on Thursday. So I'm going to sit here quietly for a few minutes. If you want me to scroll around and show you something specifically, please ask. And I will do that. Otherwise, the video will go up as soon as the video will be up in, inside of a half hour. Immediately on Twitch, inside of a half hour on YouTube. So if you want to go back and review the video, it goes up quick. I will be here tomorrow, Wednesday, at 10 a.m. like I always am for question and answer. If you have questions, you can drop in. Otherwise, I'll see you on Thursday. So we're almost there. 2 more meetings after today. See you, Jack. Jack had a long day with me. And I figured out the problem, Jack, by the way. Comment out the macros we didn't implement, and it works. Thank you, Etsu.